Spaceships with warp drive can travel to just about any alien planet as easily as we travel to anywhere in the world in a matter of hours. At maximum warp, the Enterprise from Star Trek The Next Generation can go 9,000 times the speed of light. And if you think that's fast, the Millennium Falcon from Star Wars can go 9 million times the speed of light. By comparison, the fastest man-made object, the Juno probe around Jupiter, goes a whopping 0.0002 times the speed of light. This is still super fast by earthly standards, 46 miles or 74 kilometers per second. But at this rate, it would take 20,000 years to reach the nearest alien planet, Proxima Centauri. If we had warp drive like the Enterprise, we could make it a day trip, there and back in only 9 hours. But isn't warp drive all a bunch of science fiction fantasy? Isn't faster than light travel forbidden by Einstein's relativity? Well, it turns out there's a loophole. And to be honest, before I started researching this subject, I thought this video was going to be all tongue-in-cheek. But I was shocked at the volume of real science that's been done on this subject. Turns out there's a lot of scientists who've been inspired by Star Trek. And I think you're going to be shocked that although warp drive is highly theoretical, it is based on some real physics. How would such a warp drive work? And is it really plausible? The unorthodox, crazy physics of the warp drive is coming up right now. In 1994, Mexican physicist and Star Trek fan Miguel Alcubierre published a paper on the warp drive while still a PhD student and became instantly famous. How did he figure this out? He did this by manipulating Einstein's equations of general relativity. This was a purely geometric manipulation. What you have to understand is that general relativity at its core is about the geometry of space-time. Einstein showed that gravity is a geometric warping of space-time. By manipulating this geometry to look the way a warp field would look for a spaceship, Alcubierre made the equations find an answer to the idea of a warp drive, regardless of whether it was feasible or whether other laws of physics would allow it. It was more of a thought experiment. But his equations are mathematically consistent solutions to Einstein's equations. And this is how Alcubierre's warp drive would work. Take a spaceship and put a bubble of space around it. If you can compress space in front of the bubble and expand space behind the bubble, then you can make the bubble of space along with the spaceship move. This would be like riding a wave on a surfboard. You're not moving on the surfboard, but the surfboard is moving because it is being pushed by the wave. This is where the loophole is in Einstein's speed limit, that nothing can move faster than the speed of light. This speed limit only applies to objects traveling within space, not the movement of space itself. Space can move at any speed. So that bubble of space in Alcubierre's geometric solution can move at any arbitrary speed, theoretically even 9,000 times the speed of light. Alcubierre figured out a geometry that would fold space in such a way that a ship would not move in its frame of reference, but the space that it was resting on would travel. But can space really move at faster than light speed? Our observations seem to indeed confirm this. For example, the space very far away from us at the edge of the universe is moving faster than the speed of light. Any light from galaxies or stars in this space is light that we will never see. In addition, as I showed in the previous video, space inside the black hole's event horizon moves faster than the speed of light. So this is a real phenomenon and should not be discounted. Let's look at Alcubierre's warp drive more carefully and what it is doing to the space-time around the spaceship. Space is being expanded at the back of the spaceship and being contracted in front of it. Can space expand and contract like this? Yes. Space is allowed to do both. Space is malleable according to general relativity. It can bend, stretch. Space is contracting around you and Earth right now. That's what gravity is. Similarly, space can expand too. It's expanding right now on a cosmological scale because when you look through a telescope, you can see that faraway galaxies are redshifted. The galaxies are not moving locally. It just means that the space between those galaxies and us is expanding. Alcubierre's warp drive creates a kind of bubble around the ship, which is like the surfboard. The ship sits within the bubble, analogous to you standing on the surfboard. Your ship does not move within the bubble itself, so Einstein's laws are not violated. But the bubble of space is moving or carried by a kind of wave that is being created in space. So how would a warp engine make space contract in front and expand in the back? This is not easy. Space is a fairly stiff fabric on the order of this equation. C is the speed of light to the fourth power, so this is a very large number. And to make space warp locally around a spaceship like this requires a lot of mass, or its energy equivalent via E equals mc squared, densely concentrated around the spaceship. And more importantly, this is not just regular mass or regular energy. This is negative mass and negative energy, because in order to create expansion of space, you need some kind of anti-gravity. How do you get anti-gravity? You need negative matter, or exotic matter. This is something that would theoretically have negative gravity. The problem is, negative matter is not known to exist. Note that negative matter is not antimatter. Antimatter does not have negative gravity, it has positive gravity. It's just like matter, except it has the opposite charge. So an antimatter proton would have a negative charge, and an antimatter electron would have a positive charge. Antimatter does exist, but this anti-gravity negative matter is something completely different. It has never been detected. Imagine something that weighs -1 kilogram. What does this mean? It may not even exist. Now you could substitute the energy equivalent of negative matter, which is negative energy. This comes from E equals negative mc squared. But again, what the heck is negative energy? This is not the same as an absence of energy. It is energy with a value less than 0 that would theoretically create anti-gravity and allow you to expand space-time. But anti-gravity has never been seen in a lab. There's not a known distribution of energy that can produce anti-gravity or negative mass. It has never been found in any accelerator or observed in nature. Even Alcubierre called his results nonsensical. However, anti-gravity, negative mass, and negative energy are not forbidden in Einstein's equations. Could this mean that if we are clever enough, we could create it? Let's presume that we could. There is a group at NASA called the Advanced Propulsion Team, also known as EagleWorks, who is working with this assumption. And they have even created an artist's rendering of what a warp drive spaceship would look like. They even call it the Enterprise. Alcubierre's original warp bubble around a spaceship would have required a lot of negative energy. The energy equivalent, in fact, of all the mass in the universe. So it was obviously not feasible. But further reworkings of Alcubierre's original concept by NASA physicist Harold White reduced the negative energy requirement to the equivalent of about 700 kilograms or 1,500 pounds. This is still a lot of energy, about 1,000 hydrogen bombs worth, but may not be out of the question and makes the concept somewhat plausible, if negative energy can be created. How did Dr. White make Alcubierre's engine go from nonsensical to plausible? He did this by changing the shape of the warp bubble around the ship to a torus shaped somewhat like a donut, and by oscillating the negative energy field. These changes, he said, not only makes the warp field more efficient, but also makes space around the ship more pliable for expansion and contraction. Dr. White's calculations show that a 10-meter diameter ship could go at 10 times the speed of light. Now you might say, why is there a torus around the ship? The torus is what would create the negative energy field around the ship. You would think that since space is expanding in the back, you need the negative energy directed at the back of the ship. But if you do the math, what you find is that the negative energy is needed all around the ship. That's why the ring in the concept renderings is around the spaceship itself. White's team has even tested the feasibility of warping space by doing a very small-scale tabletop test. They've attempted to slightly warp the trajectory of a photon, changing the distance it travels over a fixed length. The first test was done in 2013 and was inconclusive. Tests by other teams have shown that if such a device could be built, it could hypothetically work, but perhaps not past the speed of light. But even achieving a speed of, say, 10% the speed of light would be a huge breakthrough, because it would still be 50,000 times faster than the fastest speeds that we can achieve today. Is negative energy even realistic? Some scientists have pointed to the Casimir effect as displaying a kind of negative energy. This is a quantum mechanical phenomenon that occurs when two conducting plates are brought very close together, something on the order of 10 nanometers. When this is done, a certain proportion of the virtual particle frequencies between the plates are excluded, because not all frequencies will fit between the 10 nanometer space, whereas all frequencies will fit outside the plates. The pressure outside the plates thus is greater than the pressure inside the plates, and this can be seen in a physical attraction of the plates that brings them together. The sonic analog of this is shown in this video. So the thought is that if the total vacuum energy is 0, then this would mean that the energy between the plates must be negative. Some scientists have proposed harnessing this negative energy of the vacuum on a large scale. But this is flawed because while the energy between the plates is less than the vacuum energy, it is not negative. It is still positive. There is no negative curvature. This is not negative energy and cannot be harnessed to power our warp drive. So given the problems I talked about, is all hope lost for the warp drive? Not quite. There is one observational phenomenon that should give us hope that negative energy or anti-gravity may exist. The observable universe is expanding at an accelerating rate. This is called dark energy. See my video on that. We have no idea what it is, why it exists, or where it comes from. But 70% of our universe is made of this dark energy. And this energy behaves like anti-gravity or negative energy. Essentially, it is some kind of energy or force that's pulling space apart. It's expanding space. Well, expansion of space is precisely what we need to create a warp drive. Is it possible that sometime in the future, if we can develop a better theoretical understanding of dark energy, we can learn to harness its power and use it for the warp engine? Our universe is full of this stuff, so we could potentially have a near endless supply of it if we knew what the heck it was and how to manipulate it. Some technologies are inspired by mathematical equations. It took 40 years to go from E equals mc squared to the first atomic bomb. In the past 20 years, the warp drive concept has gone from impossible to plausible. Maybe in the next 20 years, it can go from plausible to possible. Maybe it can become reality given enough time and given more thought-provoking episodes of Star Trek to inspire the next generation of physicists. Yes, please. Arvinash here. If you like our videos, then consider subscribing and ring the bell so that you can be informed when we upload more fascinating videos. We make 1 to 2 videos a week. We'll see you in the next video.